Joe Gallagher from Veritas Education, and this is the Troubleshooting Communication Issues lesson. In this lesson, we'll discuss how NetBackup communicates, and in particular, how it makes use of TCP/IP and name resolution. We'll take a look at different types of physical and logical network errors, how to identify and troubleshoot them, and we'll discuss NetBackup configuration issues that can impact communication. We'll begin by taking a look at how NetBackup handles communication between processes and between hosts. NetBackup uses TCP/IP for all communication, and that refers to communication between hosts, as illustrated on the slide here. It also refers to communication within the host, too, when there's inter-process communication between different NetBackup services. Having a good understanding of TCP/IP is very helpful in troubleshooting communications issues with NetBackup. It's also something to kind of have tucked away in the back of your mind during the troubleshooting and optimization process, that NetBackup is sensitive to anything that TCP is sensitive to. If there's a particular firmware upgrade that improves TCP performance on a server, NetBackup performance will be improved as well. Similarly, if there's a problem on the server that's causing TCP issues, you will see NetBackup issues as well. To distinguish between application input and output flows of data on a TCP network, the operating system is going to have separate input and output queues of data packets, and these queues are known within TCP terminology as ports. There are two types of ports that are available on a server: reserved, which is 1023 and lower, and non-reserved, which is 1024 and higher. And NetBackup makes use of both types of ports in its communication. We can also make a distinction between registered ports and random ports. A registered port is a well-known address, one that is registered with IANA, and there is a known service from a specific application that is listening on that port. And so, for example, the VNetD process on 13.7.24 is using that port exclusively. No other service on that server should be using it. And generally, when you talk about registered ports, you're talking about listening. When you talk about sending, there is some port used for the transmission of data. So you have a port on each end, a sending port and a receiving port. The sending port is almost always dynamic, which means that whatever process it is that wants to send a signal to another process, it just asks the operating system for a random port, and then the port is assigned to it. Unless you're on an extremely hardened server, the sending port is not usually a major consideration. It's the receiving port you have to be careful of, because a receiving port on a different host means that data might be passing through a firewall, and the firewall would need to allow that traffic. This slide shows some of the different process communication methods used within NetBackup. Private Branch Exchange, PBX, is used by all of the newer NetBackup processes, the ones introduced after version 6, and the ones that tend to start with NB for NetBackup. PBX, they mention here, is a CORBA compliant communications protocol. A more accurate way of saying that would really be to say that PBX is an instance of CORBA, the Common Object Request Broker Architecture, and it provides for somewhat more managed and reliable communication than kind of an old-fashioned straight socket-to-socket communication. Now, a lot of what's going on here is stuff that's happening under the hood that we don't necessarily need to be involved with. One of the biggest implications, one of the positive implications of using PBX, is drastically reduced port usage, because PBX essentially functions like a switchboard. All processes that are communicating via PBX do so using a single port, 1556. Now, when PBX was first introduced in NetBackup version 6, it was really only the newer processes that are using it. In every release since then, more and more processes have switched over from using legacy communication methods to using PBX for communication. And I'm sure the eventual goal is that one day this will be the only communication method that's used in NetBackup, but we're not there yet. There are still some older processes still using older methods. And so when we talk about legacy communication, we talk about straight socket communication, straight port-to-port communication. Now, there is a possibility here to reduce external port usage when we're doing host-to-host communication via the VNetD daemon. Now, the VNetD performs the port reduction function that PBX does, but it does so for legacy processes. So the VNetD port 13724, the PBX port 1556 are the two main ports that are used for host-to-host communication and that would need to be opened in firewalls. The other two processes that are mentioned here are not really used for host-to-host communication. They're mostly used within a NetBackup server, and they both have to do with compatibility between older single-threaded processes and newer multi-threaded processes. And so BPCompatD is used for multi-threaded processes to make a connection to older single-threaded processes. Basically, CompatD is used to handshake between the two processes and get them talking to each other, and then that instance of BPCompatD can go away. NBProxy is a service that runs all the time. In fact, each process that has a need to talk to the image catalog through the database manager will have its own instance of NBProxy running. And so we'll have instances of NBProxy dedicated to NBPEM, NBJM, NBSL, and like we mentioned when we talked about process flow, NBProxy has readability to the image catalog, but not writeability. So some reads can be done directly through NBProxy to the image catalog. Some reads will go through BPDBM, the database manager. All writes must go through BPDBM. Here we see communication between two hosts, and this communication is using PBX exchange over port 1556, and this is the method by which the majority of NetBackup processes will communicate in 7.7, whether it's within a host or between two hosts, as in this example. Most processes these days use PBX. Here's an example of BPCompatD in action. Again, this is used for newer multi-threaded processes that need a way to be able to interface with older single-threaded legacy processes. Here's another example of using BPCompatD, and although it's not specified in the slide, this would be a good example of a NetBackup media server reaching out to a client across the network, where we have some of these newer multi-threaded processes that are using BPCompatD to interface with older legacy processes on the client. Now you'll notice in terms of which service we're going to be talking to on the client, there's a couple of choices over here, and this will be determined by your settings in NetBackup and the task that you're trying to perform. But generally speaking, the preferred behavior is to make connections through PBX. So most functions between NetBackup servers and clients are going to go from the NetBackup server to PBX on the client. Now, other functions may use VNetD. VNetD is the older legacy network daemon, and this was something that we were using prior to version 6 in order to cut down on port utilization in NetBackup. VNetD is listening on 13.7.24, and there's still a couple of functions in NetBackup that rely on VNetD that haven't switched over to PBX yet. And then there is also the option of using VNetD as kind of a plan B. You attempt to connect to the client over PBX, it doesn't work, let's try the VNetD port and see if we can reach the client that way. And then the third method would be a direct connection between the NetBackup server and a particular process that is listening on a well-known port on that client. And so example over here, we're reaching out to the BPCD process, which is listening on 13.7.82. Now that's a well-known port that's registered with IANA, and many moons ago that used to be how NetBackup servers always connected to clients. But it's not the preferred method anymore because we don't want to have all of these different services on clients listening on different ports. We don't want to have to open all these different ports in the firewall. We want to channel all this communication through either PBX or VNetD. So this is never the preferred method of communicating. There's very few instances in NetBackup where a specific port is referenced. NBAC is the only example I can think of offhand that still does this. All other connection methods will prefer to use PBX for the most part, or possibly VNetD. But again, this is still here as like a plan C. I tried to talk on PBX, didn't work. I tried to talk on VNetD, it didn't work. Let's try to reach out directly to BPCD. Here's a visual example of NB proxy, and again, it's allowing newer multi-threaded processes to have a thread-safe communication with the older single-threaded BPDBM. So each one of these processes, NBSL, NBPEM, NBJM, they have their own instance of NB proxy running. NB proxy is going to provide thread-safe communication by serializing requests so that there's no overlap and potential conflicts, due to communication from these multi-threaded processes. And again, the other function of NB proxy is that it is able to accomplish some read operations directly to the image catalog without even needing to go through BPDBM at all. NetBackup makes heavy use of pure name authentication. What that means is when a host reaches out to a NetBackup client or server, for example, a media server connects to a client and says, "Hey, I'm your media server, give me all your data." The client is going to take a look at the IP address of the server making this request. It's going to do a reverse lookup on that IP address and get a host name, and it's going to compare that host name to the list of authorized servers in the bp.conf file on Unix systems or in the registry on Windows systems. And if the host name matches, then it says OK and cheerfully provides all its data. If the host name doesn't match, it says, "Nope, I'm not going to talk to you," and closes the connection. And so this is a very basic level of security that's built into NetBackup. Now, if you need to get tougher with security, you can start looking at more sophisticated things like NBAC, NetBackup Access Control, because hostname resolution is certainly not airtight security. It's not that hard to spoof an IP address, but it is as much security as most places need. Now this means, because NetBackup is doing a lot of reverse lookups, that NetBackup is sensitive to name resolution in the environment. Now NetBackup doesn't really care what method you use for name resolution as long as it works and as long as it returns host names in a timely manner. And so this most of the time will involve DNS in an enterprise environment, but it doesn't have to if you're using host files, if you're using Wince. Again, NetBackup is just going to make a system call, get host name by IP address, and it just expects to get a host name back in a timely manner. Because there's a lot of communication between hosts during busy periods in NetBackup, like the backup window, that might mean a need for a lot of IP address to host name resolution. And so to reduce the amount of hostname lookups going on the DNS server, in other words, to prevent NetBackup from slamming the DNS server with a crazy number of reverse lookup requests, NetBackup clients and servers will cache hostname to IP mappings. And this is something we started doing since NetBackup 7.0.1. There's an in-memory and an on-disk cache. And this cache by default sticks around for an hour. And so after a particular IP address is looked up and matched to a host name once, it's going to just continue using that same host name for the next hour. Now that means that if there's a change to the networking configuration, if there's a change to a DNS entry or somebody edits the host file, by default NetBackup won't notice that right away. And so if we're doing troubleshooting and we've made a change and we need it to be applied immediately, the BP client command can be used to clear the host cache. You should use that command to clear the setting on disk and then restart the BPCD process to make sure you've got a clean slate. In the next topic, we'll take a look at different places in NetBackup that contain settings that directly affect network communication. Some of the settings that we'll look at are NetBackup settings. Some of them are operating system settings. This particular one here, of course, is an OS setting. It's the host file. The host file is generally, by default, the first place a server will look when it's doing a forward or reverse lookup of a host name or an IP address. Most of the time, servers are configured to check the host file first, and if there's no entry there, to check another method, such as DNS. And in most large enterprises, most of our name resolution is done by an enterprise deployment such as DNS, so that we don't have to manage individual host files on individual servers. We should always keep in mind, though, that use of the host files is still a valid plan B if we're having problems with name resolution. Particularly, we may get into very specific situations like forward resolution of a host name to IP address is working okay, but there's problems in the reverse lookup zone in DNS where IP to host name resolution is not working so great. I'm getting bad host name back, or I'm getting just a lot of time to process it. These lookups are taking a long time, and it's bogging everything down. So sometimes, putting some entries in a host file can help with that. This slide lists some of the centralized hostname resolution methods that might be in use. Again, there's no supportability list here. NetBackup doesn't care what method you're using for name resolution as long as it works. And so configuration, is done according to the vendor's specifications for these particular protocols. Just keep in mind when you're doing troubleshooting, NetBackup is very dependent upon name resolution. Forward and reverse IP to host name lookups must complete successfully, accurately, and in a timely manner, or it's gonna cause us backup and restore problems. DNS problems will very quickly lead to NetBackup problems. Here's a look at some platform-specific configuration files that affect communication. Resolve.conf gives us the IP address of our name servers. NSSwitch.conf indicates whether the server should be using host file or should be using name servers or both. We see the setting here, which is the default in most places. Check the host file first, and if there's no entry in the host file, then check the name server. This slide shows the NetBackup client name on a NetBackup client. It's stored in a bp.conf file on a Unix or Linux system. It's in the registry on a Windows client. Either way, it's accessible from the admin console, from the client properties. And for NetBackup's purposes, you can think of this as the authoritative hostname of this NetBackup client. Because a client might have multiple network interfaces, it might have multiple host names associated with it. This is the name that's authoritative for NetBackup's purposes. So the client name that shows up here should match the name in the backup policy that references this client. And if there's any client properties set in the master server client attributes part of the host properties, that host name should also match. If there's any mismatches between host names in those three places, I'm going to have issues such as client attributes not being inherited, or permissions issues when I go to do a restore, or possibly failed backup jobs. Also note that NetBackup expects you to use host names here, not IP addresses for your clients. Also stored in bp.conf or the registry for all NetBackup systems is the server list. The server list is all about permissions and who has access to connect to this host and who has access to do remote management and make changes of NetBackup settings on this host. So all NetBackup servers and clients have this list. If you're just looking at a bp.conf file, then the first server on the list is the master server. If you're looking at this through the admin console, then the console will specifically say, hey, this is the master server and this is the additional servers. And so anybody on the server list has permission to back up this host and has permission to connect to this host using the NetBackup admin console and change its NetBackup properties. Now you'll notice in this example there is one media server entry in the bp.conf file. A media server is somewhat more restricted permissions. A media server, in this case server 4, has permission to back up this host. It does not have permission to do management. If you were to take a look at the media servers tab in the master server host properties shown here, you would presumably see server 4 listed there. And this doesn't get used that often, honestly. The only reason why I would want to do this is if I had a media server at a remote site and I want that server to be able to protect clients, but I don't want them to be able to, for example, connect back to the master server and make changes. The media server entry is a form of restricted permissions. And if you don't need to restrict the permissions, don't do it. It's better to just have everybody listed as a server. Now, this can confuse folks that are new to NetBackup. If I knew nothing about NetBackup and had never taken any training, I might take a look at this interface and say, well, I've got these 4 media servers that I want to configure. I guess I should list them all in a Media Servers tab. Well, it seems reasonable, but I'm actually restricting their permission by doing so, possibly for no good reason. In most cases, what I probably want to do is to have all of my media servers listed in the Additional Servers tab, so they have full control to connect to clients, back up their data, and to change properties if I want to do that. Note the Op Center server entry, which is not shown in the bb.conf example, but you can see the Op Center servers tab in the client properties there. That's another form of restricted permissions. I can give that to an Op Center server, and it gives it enough permission to collect data from the master server to make Op Center work, to collect the data it needs to run its reports and to fire off alerts. It gives it no permission to do any management. So in a very secure environment where I was very concerned with who has permission to make changes to NetBackup configuration on the master server, I might use that Op Center server tab for my Op Center server. This slide shows the services file. I have a Unix example and a Windows example. This lists well-known ports, and it lists which process should be started when signals come in on that particular port. And so the idea here was that during NetBackup communication, when a signal was received, for example, for BPCD, came in over the BPCD port, then inetd would automatically kick off the BPCD process and hand over the communication to that process. That's sort of the old school way of doing things. In NetBackup, ever since version 7, we don't really make use of the services file in that way anymore. All processes, including ones that used to be come-and-go processes like BPCD, are now running as daemons all the time and are always available and listening on the proper port. And so this is sort of a bit of a legacy configuration for NetBackup here. These are all well-known ports. The services that are running are listening on these ports. Not all of the ports that Veritas has registered with IANA are listed here. For example, we talked about how PBX is listening on 1556, and that's a port we've registered with IANA, although we don't list it in the services file because the services file isn't really used with PBX. This is a look at the port ranges setting in the host properties. This can be used to set restrictions on ports used by NetBackup. Now you'll notice right off the bat, the big red bubble down the bottom here, that we don't recommend changing these values without guidance from support. We don't recommend changing them at all. What these are used to do is to narrow the valid port ranges that can be used for NetBackup. And the only reason really to do this is if you're in a very secure environment working with hardened servers and they're very tight on the ports that can be used for communication, even the ports that are being used for sending as well as receiving, and they want to say, listen, we're going to assign a valid port range here for NetBackup to use. It can use ports within this range and not outside of it, and we've got security services that are running on the servers monitoring this all the time, and they're going to get suspicious, if they see activity outside of this range. And so you can use this if you have to make NetBackup compliant with security protocols. The big gotcha here that you have to be careful of is if you don't give NetBackup enough ports to operate, you're going to have problems that in some cases may be difficult to diagnose. They may cause backup jobs to fail with unexpected error codes. When NetBackup reaches to have two processes talk to each other and there's no ports available for that communication to happen, it's going to fail at essentially a random part in the backup process. And so strong recommendation here is let NetBackup have unlimited use of these ports. It's not going to affect anything with a firewall, again, because that's all receiving ports that we're talking about there. This is really more focused on sending ports. Here's some different scenarios for port utilization between NetBackup. Now again, the sending is usually going to be done on a random port generated by the operating system. When we're worried about firewalls and communication between hosts, what we're really focused on is the receiving port. What port needs to be open because there's a service listening for communication on another host. And as we've discussed previously in the lesson, the vast majority of communication is all happening on PBX, which you see here in multiple examples on this slide. 1556 is open for bidirectional TCP, and most of the traffic goes along that port. Now there's still some other ports that may be required if you're using some options with Net Backup. You'll notice if you're using NBAC, Net Backup Access Control, that there are a couple well-known ports that need to be open, again for bidirectional TCP. If you're ever working with ports and firewalls and you think there's possibly a problem where you don't have the correct ports open for the features that you're using, then Net Backup Security and Encryption Guide, which is available from support, is your best friend, because there's a very detailed conversation in there about port usage in Net Backup. Opening up VNetD and PBX for bidirectional TCP will be all you need in 90%, maybe 95% of all Net Backup environments, but for those times where you are using features like NBAC that might need an extra port, check the Security and Encryption Guide for details. Here's some additional ports that we might see being used by Net Backup operations. For the admin console, which you notice primarily uses 1556, but still makes use of VNetD on 13724 for some operations. Note that they have the Windows and the Java version of the admin listed. In 7.7 and later, the Java version only is supported. There is no more support for Windows Admin Console, but you still might have older versions of Net Backup running in your environment, and you've still got the Windows version of the bar console that's running on clients to allow for user backups and user restores. And then there's other ports listed here. Some of them are specifically Net Backup, and some of them are other functions. For example, there's 2 MSDP ports that are used for dedupe activity. So if you have some kind of dedupe activity, like opdupe or error or client-side dedupe happening between 2 hosts, you're going to want those ports open, bidirectional TCP. If you've got the older versions of NBAC running back-level servers, you can see that the older ports that are used here. If you're expecting Net Backup to be able to send out communication via email, well, I got to make sure the standard SMTP port is open. If I want to use SNMP traps with OpCenter, again, I got to make sure the 162 port is open. These are not, Net Backup specific ports. These are industry standard ports, but it's still something I need to consider. If I want my traffic to get out, if I want Net Backup to send email, I got to make sure the standard SMTP port is open, or else it's not going to happen. In the next topic, we'll take a look at troubleshooting network and Net Backup communication problems. There's a lot of different kinds of communication errors that can happen in your environment that may impact backup operations. And so it's best to kind of start at the lowest level and work your way up when you're doing your troubleshooting. So begin by checking Net Backup connectivity across the physical network. If the physical network looks good, take a look at the network configuration to look for logical failures. If the logical and physical network all looks good, then start taking a look at the application level, the Net Backup level, and verify Net Backup's configuration settings. When we're troubleshooting at the physical level, check first for obvious problems. Look for error indicators on the hardware itself. Check for cable connectivity. Make sure they're all firmly seated and connected properly. Check to make sure outside communications are functioning. And there's a number of utilities that you can use in the operating system to perform specific tests at the physical level to confirm that at the physical level our network is functioning properly. This slide shows a high-level overview of troubleshooting our communications issues. So again, we're starting at the physical level, verifying that cables are snug and no error lights are flashing on the hardware, and using simple utilities to be able to see that physical communication is working. The Wireshark utility is one that's often used by Veritas support. Moving up a level to the data link level, okay, the physical network looks fine. Let's make sure we can move some packets. Let's see if we can ping. Let's see if we can trace route between hosts. If the link looks good, let's kind of move up a level to the IP level and see if we can really exchange information, actual data between hosts. FTP is a great method for this. Can I FTP a file between one host to another? Again, just to verify that the network connectivity is solid. Telnet can also be useful, especially because you can telnet into a specific port on a target server to verify configuration. If everything looks good at the IP and at the transport level, then I can move up to the application level, and here we're really at the net backup level. Are all daemons and services running, and is net backup properly configured? Net backup provides some utilities which can assist me in this process. BP client command can be used to test name resolution, so I can test an IP address or test a host name. Now, you might be thinking, what's the difference between doing this and just, pinging by IP or pinging by hostname? The difference is that instead of using a third-party program like ping, BP client command uses the exact same method, the exact same system call that NetBackup uses. So what you see with the BP client command output is exactly what NetBackup sees. That can be helpful in a number of troubleshooting situations. One of the most common is when you're trying to troubleshoot which network NetBackup is using, and you want to be able to verify that backup traffic is going across a private network and not the public network. BP client command can be very handy for that. The BP test BPCD command is similar to the old troubleshooting trick of telnetting into the BPCD port on a NetBackup client when you're trying to troubleshoot connectivity issues. The idea here is we're testing not only can I reach this host, but can I reach a particular process on this host? Can I talk to the BPCD process? And we're going to get information back if the connection was successful, and so right away I get a feel good then that the connection works. I also get information about the sockets that are used. I can see the sending and the listening ports that are used for the connection, which also might help me out. And then a third thing I can do, which is maybe not as common nowadays as it used to be, but it's still a good function to know about, is I can test different connectivity options between servers. For example, we mentioned that the default behavior for legacy processes in NetBackup is to use VNetD first, and if that doesn't work, it'll try a direct process-to-process communication as like a plan B. I could manually force communication to happen, for example, direct process-to-process using the BP test BPCD command. And this would be if I think I'm getting blocked by a firewall and I want to experiment with methods and see what's working and what's not. The NetBackup Domain Name Analyzer, or NBDNA, is a pretty sophisticated communications troubleshooting utility which ships with the product, and it's designed to go out and kind of map the NetBackup domain and collect information from the environment that might be causing communications issues. And so NBDNA discovers and maps the domain. It extracts hostname memberships by querying the configuration, and it evaluates hostname name lookup and socket connectivity, and then generates output files which can be provided to NetBackup support for analysis. As part of this process, NBDNA calls BP Test Netcon, which does a series of tests that helps out with Corba connectivity, i.e. PBX. The next couple slides show sample output from NBDNA. So after running the command, the first thing I see is just some information about the server itself, platform and NetBackup version, for example, and then it gives you an overview of the kinds of tests that it's going to be running. And so as NBDNA runs, it's testing name resolution to all media servers and clients. It's testing basic connectivity between master servers and media servers, and between master servers and clients. It's discovering and mapping the domain network, and then it's saving all of that information in an output file, which it specifies here, and then I can then provide that archive to support for analysis, or maybe I want to get in there myself and take a look at what NBDNA found as part of my own troubleshooting. PBX is one of the unified services that was added to NetBackup in version 6, which means that it's got a unified log associated with it. Note that the PBX log should be analyzed using the VxLogView binary in the PBX bin directory. PBX is a common product. It's not really part of NetBackup. It's a common utility used by a number of Veritas products, such as Storage Foundation, and so it's got its own set of binaries. It's got its own product ID. You'll notice NetBackup would normally be 51216 after the -P, whereas PBX is 50936. Just make sure you're using the right binary if you're looking to get information through VxLogView. A lot of times when you're providing this information to support, you'll really just be providing the raw log file. You won't be providing the VxLogView output. So that may not really be a big concern unless you're doing your own troubleshooting. And the times when you may be doing that may be very limited anyway, because to be honest, the PBX is an extremely dense log. It's a lot of Corba information that's in there, and not a lot of real human-friendly output. You're less likely to find, an easy cause of a problem from the PBX log than you are in some of our other debug logs in NetBackup. In addition to the utilities we've mentioned already, there are many other configuration and testing tools that are available with the operating system that can help out in network troubleshooting, several examples of which are seen on the slide. In this final topic, we'll take a look at some common NetBackup communication issues. As we've discussed previously, there's three main levels that we're doing communications troubleshooting at. The physical level, which by this point in the process hopefully we've already ruled out. The logical level. Now we've talked about port problems and network timeouts already to some extent. We haven't talked a lot about firewalls. We'll talk about that a little bit in this topic. And there's also the possibility of NetBackup configuration issues. This slide shows two status codes that are often associated with firewall issues. The status code 54 is a timeout connecting to the client, which means that we did initially make a connection to the client. However, the client did not complete that connection. A lot of times what can be happening here is there's a handoff of the port from one process to another within NetBackup. NetBackup uses port inheritance, so that one process, such as VNetD, for example, may hand off a port it's using to a different process. And some firewall software that may be running locally on the server considers that a security violation, might result in this status code. The status code 57 is a straight-out refusal to connect. So we didn't get as far with the 57 as we did with the 54. Usually this results from the server trying to make a direct connection to BPCD, and the client is refusing the connection on that port. Here are some general suggestions for troubleshooting firewall issues. First off, make sure that the correct ports are open for bidirectional TCP for the operations that NetBackup is trying to conduct. Now, as we've discussed, this generally means PBX 1556 and VNetD 13724. However, there are other ports which are required for some NetBackup functions. Again, the NetBackup Security and Encryption Guide is your go-to reference for that. Also, make sure that the TCP idle timeout setting is high enough for NetBackup. Some firewalls will shut down a port if it detects that there hasn't been any traffic on it for a certain amount of time, and that can be a problem, especially during a backup where, say for example, you're doing an incremental backup of a very busy file system with lots of files in it, and the NetBackup client is going through checking M times on the file system to see which files should be protected, and so there may not be any transmission of data, for a fair amount of time while the client is busy doing these scans. If the firewall timeout is set too aggressively, it may close a valid connection and result in failed jobs. Also, make sure the firewall is not performing NAT or PAT, neither of which are supported with NetBackup. If the NetBackup configuration appears to be valid, remember that network errors may also be caused by other settings on the server. Make sure that name resolution information, DNS, the host file, whichever method you're using, is set properly. Review the settings on the Servers tab and the Clients tab. If you're using NIS, make sure that NetBackup services are included in the configuration. And be careful with your naming conventions for clients. Like the slide says, consistent and reliable. So use host names, not IP addresses. The best practice from Veritas is to use fully qualified domain names, not to use short names, particularly in Windows environments. But the most important thing is consistency. If you really wanted to use short names instead of long names, that would be okay, as long as that's always what you do. If you mix and match between short names and FQDNs, you're going to confuse administrators. You may cause issues with backup jobs, especially if the client name in the bp.conf doesn't match the client name on the backup policy. And you're also going to jam yourself off when you go to do restores, because remember that backup images will have the host name of the client associated with the backup image, and that will affect permissions when you go to restore if you're doing user restores, and it'll also just affect your ability to search and find backup images. If everything was backed up using short name and you're searching by FQDN, you're not going to find anything in the bar console, and it's going to be frustrating. There are two potential types of port issues we can run into with NetBackup, one being a port conflict, where a NetBackup service and a non-NetBackup service are fighting over the same port. Another potential issue being a port range that has been defined too small for NetBackup. So on the slide here we see examples of commands that can be used in Unix and Windows for the first scenario, where we suspect that a port may be being used by a non-NetBackup process. The status codes on this slide can be associated with a port shortage problem, where NetBackup has two processes that want to talk to each other, but it's unable to make a socket for them to communicate because it's run out of ports. These are not even all of the status codes that can be seen in that situation. There's a fairly broad list of codes that you can get because it all depends at what point in the process things got jammed up because of the port shortage. And as you might imagine, these kinds of problems can be very challenging to troubleshoot, because it's 219 storage unit not available gets us to start thinking about device-related issues, not so much communications-related issues. But you can totally get that code from a port shortage. Now the slide recommends here some places where you can look to get more diagnostic information about this to help identify if a port shortage is your problem. As a best practice, try to make sure NetBackup always has enough available ports. Make sure that you don't set limits on the ports available to NetBackup unless you absolutely have to. Earlier in the lesson, we looked at where we can restrict the range of ports available to NetBackup. And just like we said before, if you restrict that too much, you can run out of ports and processes can be unable to communicate with each other. Now, there is a possibility here if you're required to restrict the number of ports, or if you just have a very busy server and you're running out of ports, even with no restrictions, because that can happen too. A couple things to think about. One is that you just may be trying to do too much. Port shortages on a server that have no restrictions set on it and you're still running out of ports just may be a sign that this is an overburdened server, and you may need to increase the number of media servers or master servers in your environment. Another thing that you can look at doing is changing the operating system settings on the server so that ports are recycled faster. The way operating systems generally behave is that they'll notice when there's no more communication across a port, and eventually they'll close it down and recycle it. Now you can instruct the operating system to be more aggressive about this, but you have to be careful. Increasing how aggressive the operating system is about reclaiming ports will free up ports faster. It might solve a port shortage problem, but if you get too aggressive with this, you may have the operating system shutting down connections which are still in use. There just didn't happen to be any chatter across the connection for a few seconds. And so if you recycle ports too aggressively, you can cause more problems. This slide here is discussing a scenario we mentioned previously where we think we may be having problems with a port conflict, where another application is trying to use ports that are associated with NetBackup services. And the way we check for that is pretty straightforward. We shut down NetBackup on the server and the client, and we use netstat-a to display the sockets in use. We expect that for those ports that are the well-known NetBackup ports, the ones listed in Etsy services as being associated with NetBackup processes, that we're not going to see any chatter across those ports while the NetBackup services are down. If we do see traffic across one of these registered ports, then we need to see what is this application that's doing it, and somebody has to change. Either NetBackup has to be changed to use a different port, or the application has to be changed to use a different port. And obviously best practice from Veritas is have the other application use different ports. Again, Veritas has registered the NetBackup ports with IANA, and responsible application developers shouldn't be using ports that are registered for use with another application. Here are some network timeout exit codes in NetBackup and some suggestions for what might be causing them. The 25 and the 58 very similar errors indicate that NetBackup is unable to make a connection to the client. So what might be going on here? Well, the client might be powered off, or might be in the process of rebooting, or someone might have terminated the NetBackup services on the client. VNetD and BPCD should be running at all times on the client. If you kill those services, then the media server won't be able to make a connection. This could also be happening at the firewall level rather than the host level, where the port is being blocked by the firewall. And like the slide mentions, it also could be happen if we got name resolution issues and the host name is resolving to an incorrect IP address. That's another possibility. Now the next one in line here, the status code 41 is a network connection timeout. That's a different scenario there. With a 41, we were able to make an initial connection to the client, and the client was talking to us, and then it stopped talking to us. And when a timeout is reached, when a client doesn't talk back to the server for a certain amount of time, NetBackup will eventually give up, close the connection and fail the job with a 41. Now, it may sometimes be the case that even though the client didn't send any signals to NetBackup for an extended amount of time, that's just because it was busy, processing other things. A lot of clients are available 24/7 for business operations, especially database servers like they mentioned on the slide. So maybe they're just busy handling other stuff and they didn't have a lot of time to talk to NetBackup, during the backup job. Or maybe this is one of those scenarios where we have a big file system, we're doing an incremental backup, and we're going through a NetBackup client process, checking all the modification times or the archive bits to figure out which files to back up, and it's not talking to media server for a while it's busy doing all of that checking. Those are all situations where the connection just gets closed because NetBackup just doesn't believe the client is still out there anymore. You might be able to address that problem by increasing the client timeout in the host properties, which we'll show you how to do in a subsequent slide. Lastly, the status code 54 is a timeout during the client connection process. So the NetBackup server was able to reach out and make an initial connection to the client, but it was not able to complete that connection. And so usually what happens here is the client is getting jammed up during the name resolution process. The server initiates the connection. The client is supposed to take the IP address of the server that initiated the connection, do a reverse lookup on it, and get a host name back, and compare that host name to its bp.conf or registry to make sure that that's an authorized server. And usually it's at that step of the process that's failing where we see status code 54, where either just the name resolution process is taking too long, and so the NetBackup server is timing out the connection while the client is still in the process of waiting for its reverse lookup of the IP address to return. This slide shows examples of the client timeout settings. Now these are located in the master server host properties. 2 timeouts here. The client connect timeout is 5 minutes. That is how long the NetBackup server will make when initiating a connection to the client. That's how much time it has for the connection to be established. If we were to increase this connection, that might help us out with status codes such as 54, which relate to the connection process, getting the client to talk to us. The client read timeout is the amount of time the server will wait when the connection goes quiet and when the client stops talking to the server. And so increasing this timeout may help out with the status code 41 errors. Approach both of these settings with a certain degree of caution, because note that they are not client-specific settings. I'm in the master server host properties here. These settings apply to the entire environment. And extending these timers may have negative consequences on your overall environment. because unresolvable network connections, powered off clients, for example, will take longer to time out and fail if I have increased these timeouts. Now, note that it is possible to go to the client's host properties and change the client read timeout, which might be desirable. The client connect timeout can only be modified for a NetBackup server. When you've gone through the troubleshooting process and you've eliminated physical network failures as a possible cause, and you've also gone through and taken a look at the logical settings as well, and you're really starting to think that this is a NetBackup level issue, here's some questions to ask when approaching that step of the troubleshooting process. First off, have I checked compatibility? Am I sure the client operating system is supported by NetBackup? Am I sure I have installed the NetBackup client software? And don't laugh, it's easy to kind of forget that step in a big, busy backup environment. Am I sure that the NetBackup services are running on the client and no one has gone through and terminated them? Am I sure that my NetBackup versions are in sync? Remember that a client should never run a higher version of NetBackup than the media server that backs it up. The media server should never run a higher version than the master server. And am I running the latest NetBackup version? Oftentimes, if you've got a support case open and you're doing NetBackup troubleshooting, one of the first suggestions they'll make is, let's get up to the most current release, because then we know for all known issues, that we have the fixes applied. Things to think about within NetBackup, multiple NICs on a host can sometimes cause issues. We'll show you in a subsequent slide here how we can set preferred network settings in NetBackup to help work around that. Also, authentication issues, which usually results back to improper DNS configuration, where the reverse lookup is timing out or failing. Servers with multiple NICs attached to multiple networks, particularly multi-homed servers, can sometimes cause issues for NetBackup. They have some examples here, some status codes you can see. Status code 59, where the client is refusing access. That's probably because the transmission is coming in on an unexpected NIC, which means the IP address is mapping to the wrong host name. Or hung processes, especially media manager processes. OPRD is a helper process that works with VMD for communication between NetBackup servers for media manager purposes. No output from the VM opera command, which is usually how you view the device manager from the command line. That's another symptom that VMD to VMD communication between NetBackup servers is getting jammed up because of networking issues. So some suggestions here for working around this. Take a look at the name of the system that initiated the last communication and make sure that matches an entry in the NetBackup configuration. If traffic is going across the wrong network connection, then it may have the wrong host name associated with it. We can help to regulate this by using the preferred network settings in NetBackup, which are used to force NetBackup traffic to move across a specific connection. And you can do this either by inclusion or exclusion. You can say, hey NetBackup, I want to force you to always use this connection. Or you can say, hey NetBackup, use any connection you want, but not this one, and you stay off this NIC. Or by a combination of the two. They're pretty flexible settings. Now, those of you who've worked with NetBackup for a while may have been familiar with the older settings, required interface and required network. Those were more restrictive methods of handling this scenario, and they've been deprecated in recent releases of NetBackup. The problem with required interface was always that all it allowed you to do was to take all NetBackup communication and channel it on one interface, which made it difficult to have multiple NICs in your media servers to keep it fed with data, which we often like to do to improve performance. And so the preferred network settings, the newer way of doing this, provide us the flexibility that we need to have multiple NICs in a media server to keep it fed with data to improve backup performance, but still be able to have control over which data goes over which connections. Here's an example of going to the master server host properties, to the preferred network tab, and entering some settings here to regulate communication. And like we said previously, this is flexible. I can set one connection as being preferred, but still leave the option of using others if the preferred one is not available. I can prohibit some network connections from being used. I can force NetBackup to use only a sole network connection if that is my desire. The tech note referenced here, How to 60779, goes into a lot of detail about the use of this setting. And also keep in mind that after you make changes using these settings, you're going to want to go through and test it to make sure your hosts can still communicate properly. Some of the NetBackup utilities that we have mentioned in this lesson, in particular the BP Test Netcon utility, and to a lesser extent the BP Client Command utility, can be used to verify that, first of all, the server is still able to talk to people, that I didn't shut down all the connections for NetBackup's use, and also that when it does communicate, it does so using the appropriate network. Authentication issues can cause problems that mimic communications failures. Now these are associated with NBAC, NetBackup Access Control, which is a set of packages for authentication and authorization, which are included with NetBackup. They're installed automatically and there's no license for them or anything like that, but they are not configured automatically. Activating NBAC in your environment is a deliberate action. Now, if you are using NBAC, that means that you've kind of locked down on users and groups and probably set some specific restrictions on which actions specific users are able to do. So it means that folks are logging into the server oftentimes with an identity other than root. And so the bpnbat command is used to log in at the command line level to identify who you are and to determine what your permissions are. You see some examples at the slide here of using bpnbat-whoami to verify that you're logged in as the user that you think you are, and also an example of updating expired credentials. Because if you just leave a terminal window open for a long time when you're using NBAC, the credential will eventually expire and it will force you to log in again. Also, make sure short name and FQDN resolve to the same IP address. Always a good idea, but particularly sensitive to that when we're using NBAC. And they also show you here in the slide some debug logs, which are particularly helpful when troubleshooting authentication issues, as well as pointing you towards a very useful tech note, How to 89914, which is troubleshooting topics for authentication and authorization. Last thought here in terms of NetBackup troubleshooting, make sure the appropriate services are running. BPCD and VNetD should be running at all times on clients, whether they're Windows or a Unix client. If these services are not running, then NetBackup will be unable to make a connection to the client and back it up, and it'll look a lot like there's a networking problem where the client is unreachable, when in actuality, the actual host is reachable. It's just there's nobody there to talk to because somebody went and terminated these services. Also keep in mind that newer processes communicate by PBX, as do many of the older processes these days. If the PBX exchange service is shut down, then new connections will be unable to be made. Existing connections are likely to persist, but we won't be able to start any new ones. And a big smoking gun for this is if you ever see in job details or debug logs a lot of CORBA errors and a lot of complaints about CORBA connections. Remember, PBX is CORBA, and so those errors might indicate that this service has either hung or abnormally terminated. In this lesson, we learned about the approach to take when troubleshooting communication issues. We looked at physical network issues, logical configuration issues, and NetBackup issues, and some suggestions for workarounds.